Hi everyone, Ryan Baxter here, and today I'd like to give you a quick demonstration of one of the newest projects under the Spring Cloud umbrella called Spring Cloud Kubernetes. Spring Cloud Kubernetes is a project that is meant to help Spring Cloud users integrate their applications with Kubernetes, so taking advantage of service discovery and configuration and things that Kubernetes provide out of the box at a platform level inside your Spring Cloud applications. So Spring Cloud Kubernetes, as always, can be found on GitHub under the Spring Cloud organization and was first released as part of our Greenwich release train. So you can find it in our latest Greenwich release, Greenwich SR1. So to get started, I have a couple of applications I like to use for a demonstration here. Now you can imagine these applications kind of like a very basic e-commerce type of application, right? So there's a couple of services here called Fashion, Bestseller, Hot Deals, and Toys Bestseller. These just return some items, basically like fashion items or toys or any kind of deals that might be happening in this fictitious e-commerce site. And then there's another project here called Gateway. This is a gateway that sits in front of these services leveraging Spring Cloud Gateway. All these apps right now are very basic boot apps, right? If you just look at the Fashion Bestseller application, really all it has inside of it is a REST controller that just returns a static list of items. Okay, so nothing particularly interesting or complex happening here. And right now, if you were to look at the POM of these applications, it's leveraging Spring Cloud. And right now, it's just really taking advantage of things like Eureka. And in the case of the gateway, right, we obviously have Spring Cloud Gateway on the Classpath and Hystrix and Ribbon, right? So these are all kind of traditional, well-established Spring Cloud projects that have been around for quite a long time that I'm sure if you're familiar with Spring Cloud, you are familiar with most of these projects. So what I'm going to do here is just show you how the applications work locally using something like Eureka. And then I'm going to show you how easy it is to then deploy these same applications to Kubernetes and take advantage of some of the functionality in Kubernetes with Spring Cloud Kubernetes. So I already have a Eureka server up and running, but what I'm going to do here is start these applications. They should all start up and then register with Eureka. And then I'll go ahead and start the gateway application after everything has started up, all the other services have started up. So for example, if we go and look here and we go to Eureka at localhost /761, all right, we should see all the services now registered with Eureka as you would expect. So if we go ahead and start then the gateway, it should also start up fine, and again register itself with Eureka as well. So just to give you a quick idea of how some of these apps work, right? If we go here and we make a HTTP request to, let's choose the Toys Bestseller application that's running on 8081. So if we make a request to 8081 at Toys/Bestseller, you can see it just returns a list of items. And this is the same basic functionality for both like the Fashion service as well as the Hot Deal service. So if we just take a look at the gateway, for example, and that's running at, I believe, 8070, right? So 8070, and again, this will proxy over to each individual service, so we can hit the Toys service through the gateway if we wanted to. And there's also this concept of a start page which aggregates their data from all three of the services together. This is something that's part of the gateway itself. So if we make a request to the gateway at /start page, here you see we get a response back that has all the data from all three of the services. So we have a fashion response, we have a hot deals response, and we have a toys response. Now the gateway adds some additional functionality, particularly one of the things we have built into the gateway app is circuit breaker functionality around the different services. So if the services take a long time to respond for whatever reason, the gateway will fall back to a default request. So we can kind of simulate this using a tool called Chaos Monkey, which will randomly inject latency into the REST controller. So I can make a post request to that toys bestseller service at this actuator endpoint, enabling Chaos Monkey, which will therefore enable this random latency. So when we do that, and then we hit this start page application, eventually that random latency will happen, and you'll see it happen just there. And the toys response times out because it takes too long to get the data back, and we get this fallback of just an empty array, right? You could do something creative here, like return to cache response if you want to, but basically we just turn an empty array and we signal the response type is a fallback instead, while the other services return just fine. All right, so now that we have a basic idea of how these apps are working, let's take a look at how we get them running in Kubernetes. Now the goal of Kubernetes is to take advantage of all of those familiar Spring Cloud concepts like configuration, external configuration, service discovery, and basically do that seamlessly under the covers based on whatever's on the class path, right? So if I'm in an environment where I want to use Eureka, I can use Eureka, but if I'm running in Kubernetes, I want to take advantage of Kubernetes, but I don't want to have to make changes to my code in order to do that. So the first thing you need to do is add Spring Cloud Kubernetes to your class path. So or on your class path. So if we go to, for example, the fashion bestseller app here, and we want to add Kubernetes to the class path, we're just going to add a dependency, or Spring Cloud Kubernetes to the class path. We're just going to add Spring Cloud Starter Kubernetes, just like you would do for pretty much everything. Oops. Everything in Spring Cloud has a starter for it pretty much, so we just add the Kubernetes starter to our class path. Now we need to do a little bit of magic, right? Because when we are running in Kubernetes, we don't necessarily want Eureka service discovery to be active and be searching for a Eureka server. And also, if we're not running in Kubernetes, we want to take advantage of Eureka. So we need to have a way of enabling and disabling based on the environment that we're running in. So this can easily be accomplished with profiles. If we go into like the default application.yaml, we can go here and we can say, we can make that a little bit bigger. We can go and say Spring Cloud Kubernetes enabled, and we'll set it to false. So by default, when we just run the application with no profile set, we're going to disable the Kubernetes functionality because we're not going to be running in Kubernetes, so we don't want to be trying to use any of that stuff. But if we add a new properties file or YAML file here, so I'll call it application-kubernetes.yaml. And in this properties file, what we're going to do is say Spring, make this bigger for everyone, Spring Cloud Kubernetes enabled equals true. And we're going to disable Eureka in this case. So say Spring Cloud Eureka enabled false. Let me just make sure that is correct before I go any further. Spring Cloud Eureka enabled false, right? Okay. So that looks good and fine. So now we have a way of enabling and disabling Kubernetes or Eureka based on where we're deploying the application. Now, the nice thing about Spring Cloud Kubernetes is that it automatically activates this Kubernetes profile when it detects that we are running inside of Kubernetes. So Spring Cloud Kubernetes has a way of identifying that we're running in a Kubernetes environment. We're going to enable this Kubernetes profile. So when that automatically happens, this protocol becomes active, enabling Kubernetes and disabling Eureka. So that works to our advantage, and a little bit of magic that happens behind the scenes with Spring Cloud Kubernetes. Now, if you're familiar with Kubernetes, basically Kubernetes will run a set of Docker containers. And actually, sorry, this is not right. This should be Eureka client enabled equals false. Sorry, I had that wrong. Okay. So if you're familiar with Kubernetes, basically what we also need before we can deploy anything in Kubernetes is a Docker container. Now, I actually have Docker files already set up for all of these applications, so we don't have to bore you with that. The reason I don't want to bore you with it is because this Docker file looks pretty much the same for almost every boot application you deploy, right? If you look under the Spring guides, so if you look under Spring guides Docker, you'll find this getting started guide for deploying boot apps to or building Docker containers with boot apps. And so the Docker file that you'll find here is pretty much the same for almost all boot apps. There might be small tweaks that you need to make here and there, but for the most part, they look exactly the same. And I've already created Docker files for all of our applications here, so we don't have to bore you with the details of doing that. For the sake of time as well, I've already added this necessary Kubernetes dependencies to these other projects, as well as I've already added the profile-specific application configuration files here for these projects, so we don't have to go through and do that again. But that's basically a pattern that you'd repeat through for your applications that you want to deploy to Kubernetes. And the other thing that Kubernetes requires is some YAML configuration in order to specify things like the container that you want to get deployed, things about how ports, about what ports are running in that container, things like specific accounts for permissions that application may need when running inside of Kubernetes, ways of exposing that container optionally to the broader network, or maybe you just want to keep it exposed inside the network, inside of Kubernetes, and not expose it publicly or anything like that. So there's a lot of different configuration that goes into creating and deploying applications to to Kubernetes, and they do this through YAML. And if you've ever looked at those YAML files, it can be quite robust and a little bit overwhelming. Even after playing with Kubernetes for a while, you still find yourself going back to, or at least I find myself going back to the documentation to figure out what the correct YAML is and the different properties and all this other stuff. So it can be a little bit overwhelming to do that. So for that reason, there's a number of tools that are emerging in the Kubernetes space that helps you generate this YAML and make it a little less robust and overwhelming for the developer. And one of those tools that I've recently come across and kind of enjoy using is something called AP4K. So again, if we Google this, AP4K and this is also a project on GitHub. This takes a little bit of a different approach than I've seen other tools do to creating the YAML. Basically, it's an annotation-based approach for the most part. So you can add an annotation to your application called @Kubernetes Application, and you can add some configuration here to basically generate all the YAML that your application needs in order to be deployed to Kubernetes. So you don't have to remember a lot. It's a much more fluid experience for a Java developer to do, and I kind of enjoy using this to get me started pretty quickly. So I'm going to take advantage of that here in our demonstration to generate all the YAML that we need for Kubernetes. So here in our parent POM, I'm just going to go ahead and add the AP4K dependency to our dependency management section in our parent POM. So I'm going to do AP4K dependency management. So add this dependency. They have a starter as well called Kubernetes Spring Starter, which is a AP4K specific Spring starter, which does a couple of nice things for us around Spring Boot specifically. Like it will automatically detect that we have a REST controller and find the port that the application is using. It will also detect that we're using Spring Cloud Kubernetes and do some special stuff for us. So there's a lot of nice functionality built in around Spring specifically with AP4K. So I'm going to go back up to our fashion bestseller here, and I will add the AP4K dependency here as well. So AP, actually, have a nice little shortcut for it here. So we add our AP4K dependency. And now we're going to go ahead and add our starter. I'm sorry, not our starter, but our annotation to the main application class here. So if we say Kubernetes application, so I'm going to do a little bit more here in my Kubernetes application annotation, and I'll explain basically what's happening here. So Kubernetes has the concept of liveliness and readiness functionality. So the platform will check these endpoints to make sure that the application is up and available. And if for whatever reason these endpoints don't return 200 requests, then it will mark the application is down and it won't be accessible. So we can take advantage of that easily here by, again, customizing some of the properties in our @Kubernetes application annotation by specifying, hey, hit the actuator health endpoint. If that's up and running, then that's returning a 200, then this application is generally healthy and accessible. The other thing I do here is expose this application as to the public internet via a node port. So this is one way of exposing the application so that we can actually hit it in Kubernetes and actually get data back from it. And also, this is kind of more of an optional thing here. I just say to specify that what the image pull policy is, right? So we're basically always pull the latest image from Docker Hub in this case, where the container is going to be publicly available. So with that, we can go ahead and run our build, and AP4K will generate all the YAML we need for us to deploy this application to Kubernetes. So we'll take a look at that. If I just run maven clean package, and I'm actually just going to tell it to skip tests so we can get it to build a little bit faster in the interest of time. And actually, I'm building all the projects, but that's okay. I only wanted to build the fashion project, but this will work as well. So after this finishes running, if we go back to IntelliJ and we look in our target directory, we have under classes, there's a meta-in folder, and then there's an AP4K folder. And under here is either our, you could deploy it to Kubernetes using JSON or YAML. So either JSON or YAML, but they're both equivalent. But if we look at this here, this YAML file, you can see how much YAML actually gets generated for us. With all this YAML got generated for us with just a couple of lines in our annotation, right? So imagine having to remember how to write all this stuff by hand. It can be quite overwhelming and something I know I don't want to do, so I imagine that most other developers don't want to do either. But you can see here, generating the liveliness probe, to actuator health, the same thing with the readiness probe, right? It automatically detected the port the container is running on, or the application exposes, which is 8082. It does some other stuff up here. There's a small bug in AP4K right now where it generates multiple service accounts, um, um, which will be fixed shortly, but it's not going to hinder us too much. But so we could take one of these out. But anyways, it generates a service account as well as a role binding for us, because it detected that Spring Cloud Kubernetes on the class path, and Spring Cloud Kubernetes needs permission to use the Kubernetes REST API, and so it's given the application permission to do that. And it also generated a service for us exposing the application via a node port so that we can access it publicly as well. All right, so a lot of stuff happened for us with just a little bit of code. Now what I'm going to do in the interest of time is actually apply a git patch that's going to make these same changes for the rest of the applications here. So if I just go ahead and apply patch, and I'm going to apply this AP4K patch here. So it's going to go ahead and make very similar changes to the rest of the applications as well, so that they all have AP4K on the class path, and they all have that annotation now, the @Kubernetes annotation in their main application file, right? Okay, and they all look pretty much the same. So I'm going to again run the build just like I did before. It's going to generate the deployment, the Kubernetes YAML for all of my applications, and then we can start deploying things to Kubernetes. Okay, everything is done building. Everything should also now have Kubernetes YAMLs here. Okay, so that looks good. So now we can start deploying things to Kubernetes. Now I have a local Kubernetes deployment or cluster running on my machine using Docker Desktop. And I have a nice little tool here called Kubernetes, which helps me kind of just visually see what's running inside my cluster. Right now, there's nothing really happening here. We have nothing deployed. There's one thing I've already got set up here, which I'll show you, and that is a config map. And this config map can be used to externalize application configuration. And Spring Cloud Kubernetes automatically will use config maps with the application name as part of the application's properties when the application is running in Kubernetes. So you can see here I have one property in this config map called Chaos Monkey enabled false. And if you remember what we did earlier, when we enabled Chaos Monkey, we had injected some random latency into the application. So we're going to use this property for our Toys bestseller application to enable or disable Kubernetes a little bit later on in the demo. But besides that, this is just a very basic Kubernetes deployment. There's nothing running right now. So we're going to get some stuff running. So now I can go into each of my applications here. So if I go to the fashion bestseller application, I can say kubectl create and point it at the Kubernetes YAML that AP4K generated and deploy my application. So if I go ahead and run that, it's going to go ahead and deploy everything. You can ignore these errors. They're due to the duplicate service accounts that AP4K is generating, which I said is a little bit of an error, but basically they just get ignored when deploying things. So They show up here, but they're not affecting anything. But if we go back here, we can now see we have a deployment for the fashion bestseller. We have a pod that is going to be running here shortly, hopefully, and we get a service which got created, and then we have an account. It should have, it just didn't look like it refreshed itself here. Let's see if we can come back to this in a second, but the account says fashion bestseller was created. Let me just try this again. Oops. All right, yeah, so now we see the account here as well. Okay, so let's do the same thing for the rest of the services. So, well, actually we can, let's just test this out here while we're here. So we can, for example, let's find out the node port for the fashion bestseller application. So if we view the YAML here, we'll see that the node port that was assigned was 31343. So if we go to HTTP, oops, and then hit fashion/bestseller, there we get some data back from that. Okay, so we have our fashion application running in Kubernetes. Now, like I said, let's go back and deploy the rest of the applications here. So kubectl, and for the toys application, and again for the hot deals, we will do the same thing. kubectl. All right, so if we go back to Kubernetes here and we look at our deployments, we have the hot deals and toys applications being deployed now as well. It's probably pulling down the containers. So look at the pods here. These should be up and running momentarily. It doesn't take usually too long for things to happen. You'll see that we have now the accounts that are created for these individual apps as well, and we also have or the services for everything created as well. So let's give this a minute to go ahead and deploy. In the meantime, we can look here, because the next thing I want to do is show something in the toys bestseller. So I'm going to look up the node port for the toys application. We're going to copy that. Let's check and see if everything is up and running. So toys is up and running. Hot deals is up in the process of coming up. While that's happening, I'm going to go ahead and deploy the gateway as well. Oops. And type. There we go. And kubectl. All right, so the gateway is now being deployed, and that's being created. All right, so what I wanted to show in the toys bestseller application. So if we go to local host, and that's the node port for the toys application. We go to actuator/env. Here you see, so one of the features of Spring Cloud Kubernetes is leveraging that config map that I pointed out. So we can see here the config map value being created or being pulled from Kubernetes. So we have that Chaos Monkey enabled values false from Kubernetes. So we can see that contribution happening here in our configuration properties. That's one of the features of Spring Cloud Kubernetes. The other thing I wanted to show was at the health endpoint. another feature of Spring Cloud Kubernetes, and that is that we are contributing the health status from Kubernetes for this application to the health endpoint. So we can see information about the pod IP, the pod name, the namespace inside of Kubernetes that it's deployed in, the service account it's using, the node, the host IP, all the stuff, right? So that's all there. Now the gateway should be, it's almost there. Hopefully it starts fairly soon, because the next part of the demo will be to, there it is, will be to demonstrate that functionality. So let's take a look at the node port here. Okay, so here we have the node port for the gateway. Okay, so let's try hitting the gateway here. So that's the node port, and we go to start page. Here we see the response back from the gateway. All right. Now what I'm going to do is go back to Kubernetes and go to that config map, and I'm going to go here, and I'm going to edit this to turn on Chaos Monkey to enable that latency. So we're going to switch that to be true. And if I apply that, this should now be true. And if we go to the actuator env endpoint, we see that this Chaos Monkey value is now true. So we should have some random latency happening. And if we hit that start page repeatedly, you'll probably see this happen, latency happen eventually. Whenever a Chaos Monkey decides that it wants to inject that latency, there it is, to see the fallback happen here. And obviously, since the gateway is able to proxy all these requests, the gateway itself is taking advantage of service discovery. You can see here, which I didn't show you the code before, actually it's right here. If you look at these endpoints, basically we have these load balance URIs, routes for the gateway, and this is just basically saying these are just service names, right? These aren't host names, these are service names, right? So it's taking advantage of this load balance protocol. Basically, in Spring Cloud Kubernetes says, okay, this host name that's in this URI is actually a service name. Go ahead and look up that service name via service discovery and replace the service name with the IP address to the service, and then make the request there. So this works regardless of the service discovery implementation. So we start working with Eureka, but we also see it working in Kubernetes as well, taking advantage of the service discovery functionality built into that platform, right? So if we look at what our deployment names are, right? These match. Fashion bestseller, that matches, for example, the name here of the service name that we're deploying, specifying in the UI. So that's just a quick demo of Spring Cloud Kubernetes. Of course, if you have any questions, you can always ask me, Ryan Baxter. Reach out to me on Twitter at Ryan J. Baxter if you want, and let me know what you think. Thanks.